Hello everyone, welcome back. So in this video, we are going to understand the contest problem, weekly contest for 89. And the problem number first we have is toggle light bulbs. So let's go to the problem statement itself here. So let me first zoom little bit. Okay. So the thing is we have the question toggle light bulbs. Okay. The question first from weekly contest 489 we have. And the question saying that it's really complicated because the most of the people overcomplicate this problem. They start thinking about a perfect square, divisor, math tricks, but this one it's actually much simple. Okay, or simpler we can say that. Today I'll show you how to solve the toggle light bulb problem in a very simple concept. Okay, so let's try to understand how to implement it. Very first, the question says that you are given an array that is called bulbs of integer between 1 and 100, right? So if you come down a little bit here, you see the bulbs is an array of integers and it contains the integer between 1 to 100. And there are 100 lights bulb number from 1 to 100. All of them are switched off initially, as you can say. The initially it is switched off. For each bulb bulb at I means the element in the bulb means each bulb, we can say is if the bulb light is currently off, switch it on, otherwise switch it off. Okay, we have to return the list of integer denoting the light bulbs that are on the and sorted in ascending order, but it is saying if no bulb is on, return the empty list. So we have given this array called bulbs, and there are 100 bulbs number from 1 to 100, and all these bulbs are initially off. This is what the question says, that right? Let me go down a little bit. So let's see this example. Okay, so for every number in the array, let's suppose from here I'm saying all the bulbs are initially off. So every number in the array, if the bulb is off, we have to turn it on. If it is turned on, we have to turn off, right? So as you can see, we have given 20th, 30th, 20th and 10th. So these bulbs are currently switch off, so it's you have to switch on. You will do if this bulb is, let's suppose the very first time it was came here in the array, so we have did the switch on, right? So again it came 10 again, right? So it should be currently on, and so it should be now off, right? So at the end we have to return the list of bulbs that are on, right? So let's check how many bulbs are on. So as we can see, these are the bulbs are on, right? And the 10 is switch off, right? Now so the 20 and 30 we can say is a output, and this is what we can see here. So if you talk about the key observation or the intuition, so the bulb or a bulb stay on if only if the toggle odd number of times, right? Let's suppose it is coming two times. Very first is coming first time here, second time coming here. How many times we have here the frequency, the or occurrence of the 10 is occurrence is 2, right? So if the occurrence is 2, basically it goes to off, because the very first time it comes, we make it from switch off to switch on. It comes second time, so from switch on to become switch off. Similar kind of things will happen. If the very first time coming, let me tell you what I am trying to say. So I am saying, let's suppose if we can say if toggle is on, right, means let's suppose how the toggle is there. Maybe it is coming the first time, right? As we came here the very first time, right? It means it should be on. If the toggle comes first time, it's on, right? Because currently it was switch off, now it is switch on, means it means the on. Similarly, if we say it is coming two times, right? If it is coming two times, means very first came here, it was switch on, now it is switch off, right? So it is called off. Then we'll say, okay, if 3 times comes means what? Basically, it comes to the 1 again. It will become, because from off, now it will become on. It comes the 4 times, right? What will happen? It become off now, right? Because initially it was off. The first time came, first occurrence on, second time off, third time on, fourth time off. Like that, we can say that. So this problem reduces to which numbers appears at odd number of times, right? If you see, if it is odd number of times, if it is odd number of times, so these times it becomes nothing but on, right? Odd number of times, odd number of times, right guys? So these are the number are odd numbers, odd number of times we can say. And then this problem got reduced to here. Means this problem reduces to become which numbers appears on the odd number of times, right? And this is called, if you remember, frequency parity, right? So based on the frequency parity, we have to check. So this is not a math problem, guys. This is not a divisor trick we will do, but this is a simple counting you can do and you can find out. So if we'll talk about the optimal solution, right? So we know that bulb range is from 1 to 100, right? We know that. And that's a small and fixed number. So the best solution, we use a binary array of 101, right? As a binary, not binary, we can say a boolean, right? A boolean array of size 101 we will take, because 1 to 100 we have. So we just need to say, like, let's suppose, how about I'm trying to say, we just need a state, right? And we'll pass the number, right? If we can pass this and we'll check, okay, if it is not, the state is true, means the number we are talking about. If it is not true, so we'll use this every time we see a number. So every time we have to see the number, right? And we have to toggle it like this, right? We have to toggle it like this. Okay. So at the end, the loop from 1 to 100 we have. So we'll loop from 1 to 100, right? And we'll collect the bulbs that are true. If the bulbs are true, right, then we will add into result, or you can say we will collect it, right? So we know that all array is already sorted, right? And that's we have done already, right? So if the array is already sorted, right, so what is the time complexity become, right? So we know that if we'll try like that, it will go for O of 1 time complexity, because O of 100 is nothing but it's a constant time, right? So it will say S of not S of O of 1 we can say as a space complexity, right? So let's go to understand the code, guys. Very first, we have given these states. Let me zoom out a little bit. So we have this state we have, and we'll use from 1 to 100. We have toggle, right? So we have to toggle the bulb. So we'll check each bulb. If the initially every bulb is on, so we have to make it off, or if it, sorry, it is off, so we have to make it on. We have to collect all the bulbs that are on now from the series, right, that we have seen, and then this is our result. So for each eye we have to traverse, and we'll check if the state is on, we have to collect into the result, and then we'll return. This is what we are talking about. If the state is still on, we will add into the result, right? So let's do the dry run so you will understand. So let's talk about, we are going to use this one, right? So very first everything is switch off, right? So we'll think that okay, let's go to traverse over this array. So we'll traverse over this array, right? So all the bulbs will come here. Very first we'll check the 0th bulb, right? This one. So this is, if it is off, we will mark it as a on. So this become switch is on. Now we'll collect the result, right? So we have to collect it also. So oh, sorry, so first we will traverse all the bulbs like this. We'll keep continuing the all the bulbs like this, right? And then once these are done, now we have to collect at the end that these are which are the on. So we'll check, okay, go with 1 to 100 again and check if the state of the bulb is what you call is on. Then we will add into the result, and what this is doing, we will see, okay, now 20 and 30 are on and rest are the off. We will return the result in the result set. So we are adding into the results, and this is what we have created the result. Okay, so we, no sorted needed here, no sorting is needed here, guys. We just need to scan from 1 to 100, and it's already ascending, right? So it will work fine. That's a clean thinking, right? So alternate approach is that if you can use hash set, if number not present, add into the hash set, right? And if already present, you can remove. And at the end, sort the set, right? But add the unnecessary sorting, and boolean array is faster and simpler. So in the interview, this approach wins. A simple approach is wins, right? You don't need to use the has set and hasing things, right? This is what I have, guys. In case you are learning DSA, you can join my online classes, and that's all I have in this video. Thank you. But if you are in the interview, when you see the toggle operations on of a state, just repeated numbers are there, immediately ask if the final state determined by order even frequency. That single habit makes you a stronger problem solver, right? And stop brute forcing. Okay, that's a start of the pattern recognition, you can say, in the interview itself. So if this explanation makes it clear, please comment parity master below. And if you want to more interview questions, right, and like this, you can join our YouTube channel. And let's go to understand next question for the contest 489. Thank you.